Hi girls. So this is the second part of 2019 question 10 part B, and what we're trying to do is we've just worked out the amount of moles of the reactant that we started with, the amount of product that we produced, and now we're doing the next part, which is asking for the number of mercury atoms. Okay, so in the question we're given the original equation for the reaction, but we're also given these other three equations underneath that, which tell us how each of the products deteriorate or break down. And the first one refers to mercury, as you can see that here. So this tells us that 1 mole of mercury sulfide produces 1 mole of mercury. Because in the original reaction we produced 0.01 moles of mercury sulfide, that means that if we started with 0.01 moles of mercury sulfide here, we're going to produce exactly the same amount of moles of mercury, which is 0.01. So the only remaining question for us to do is to work out the number of mercury atoms. And that's really, really easy to do. All we have to do is take our atomic number, our Avogadro number, 6 by 10 to the 23, multiply 0.01 by 6 by 10 to the 23, and we get our total of 6 by 10 to the 21 mercury atoms. So that's really, really easy to do. And we know we've got the right answer there because we expect a very large number when we're asked about amounts of atoms, don't we? So the last part of the question asks us for the total amount of moles of gas produced in all the reactions. So remember, there are 3 reactions here, and each of these produces a gas. We can tell that really easily. If you didn't know the names of them anyway, you'd know because there's a little G in the beside the formula for each one that's a gas. So sulfur dioxide is a gas, carbon dioxide is a gas, sulfur dioxide here is a gas, and both of these, CN2 and N2, are gases. So literally we have to total up the amount of moles of each of these produced. And again, that's really, really easy to do. What I've done is here, you can see at the very start, we worked out that we have 0.01 moles of reagent at the start, and that gives us 0.01 moles of mercury sulfide, 0.005 moles of CS2, and 0.005 moles of C3N4. So each of these products then decomposes according to each of the 3 equations given to us. So we're going to start with equation 1 with 0.01 moles of mercury sulfide, and it's really easy to work out how many moles of sulfur dioxide that's produced, because obviously that's going to be the same amount, isn't it? Because 1 mole of this produces 1 mole of that. So if we started with 0.01 moles of this, we finish with 0.01 moles of that. So the total amounts of gas produced from equation 1 is 0.01 moles. The mercury obviously isn't a gas, so we're just adding up 0.01 and that's it. In equation 2, we started with, remember up here we produced 0.005 moles of CS2, so we're going to start with 0.005 moles of CS2, and we're going to work out how many moles of CO2 and SO2 that produces. And again, that's easy to do. 1 mole of CS2 produces 1 mole of CO2, which is 0.005. 1 mole of CS2 produces twice as many moles of SO2, so that's 0.005 times 2, which gives us 0.01. So all in all, we produce 0.005 moles plus 0.01 moles of SO2. So we add them together and we get 0.015 moles of gas produced in reaction 2. Right, so then we have reaction 3 to do. This is C3N4. And again, we're going to use our ratio here. So we started with, if we go back to the top here, you can see we started with 0.005 moles of C3N4 because that's the amount we produced originally. So we're starting here with 0.005 moles of C3N4. So using our molar ratio here of 2 to 3, we're going to divide 0.005 by 2 and multiply by 3, like that. And we're going to get 0.0075 moles. Like that, sorry, I was out of focus there. 0.005 divided by 2, multiplied by 3, 0.0075 moles of CN2 produced. And then you can see the molar ratio here is 2 to 1 for nitrogen. So we're going to divide 0.005 by 2 to find the amount of moles of nitrogen produced. And that's 0.0025 moles. All right, so now we tot up 0.0075 plus 0.0025 and we get 0.01 moles. So the final part then is just to add up these three numbers from the total moles of each of the three equations, 0.01, 0.015 and 0.01 like that, and we get 0.035 moles. So I've added up this, plus that, and I get 0.035 moles of gas produced. Bit of a squash there at the end, sorry about that, ran out of space. But you get the idea. Okay, so hopefully that helps. And that's a difficult enough moles question, but it's very similar to some of the moles questions that have come up over the years where they use multiple equations and you need to work through from the amount of moles from the start to the amount of moles produced at the end. So maybe now you guys could try a couple yourselves. And if you're having any problems, let me know which ones you're having trouble with and I'll try and have a go at them. Okay, that's it. Bye-bye.